Audio Jungle. Audio Jungle.
The longitudinal static stability always talk about the pitching moment. We'll talk about the pitching moment. Okay, one by one I will write. It will talk about the pitching moment. In case of the longitudinal static stability, we'll talk about the pitching moment, and this pitching moment will have nose up, also called pitch up. We have nose down, also called pitch down. This is the second very important point. Now, about which axis this nose up and nose down or pitch up and push down is what happening. So it is about y axis, which is nothing but lateral axis. Am I right? This one is clear.
Yes, sir.
Right, this one is clear. Okay, so coming to this uh, longitudinal static stability. So this longitudinal static stability, if we want to find out for the complete aircraft, so we have to go for the component wise. Okay, component wise for the aircraft is what divided basically in three major parts, three major component, which is nothing but main wing, fuselage and tail wing. So longitudinal static stability, we have to check first for the main wing, then we'll check for the fuselage, and then we'll check for the tail wing. These are the our next move, like how to proceed this longitudinal static stability, because this is the lengthy one. So component wise we'll do first. So if you check the aircraft component. Okay, so we are talking about the major components. So all three major components are basically main wing, we have a fuselage, and then tail wing. All right, so for the study of the longitudinal static stability, one by one we have to discuss here. Okay, now main wing we are going to talk. But before going into that, I also want to tell you, like, if you say longitudinal static stability, means we are talking about the pitching moment. And if pitching moment we are talking, so that means nose up and nose down, right? If we are talking about the nose up and nose down, so that pitching moment coefficient with respect to angle of attack, we have to check the sign convention. We have to check the sign convention. Okay, now how it happens. So we just mark this longitudinal static stability, where we are going to talk about the pitching moment. In this pitching moment, two things are there, especially pitch up, pitch down. Okay, pitch up means nose up and nose down. So now I'll take the simple case, two different cases I have now. Okay, suppose this airplane is what simply flying like this. Airplane is what simply flying like this. Okay, all right. Now once disturbance came, okay, so this airplane is what hit with the disturbance. So this is before disturbance, and next is after disturbance. After disturbance. So in case of the after disturbance, two options are there. One, both I will draw here. This is my reference line for the plane. One option, it will have a nose up. Okay. Another we have a nose down. Another we have suppose nose down. Another we have suppose nose down. Huh? Disturbance means what? That what is the mean of disturbance? If I say disturbance, then what is the mean of?
That's
So two
the
types of
turbulence.
yes, two types of disturbance we have. One is the gust, which is the turbulence basically. Okay, turbulence of air. Okay. Another is the it's a pilot control input. In that we have a control surfaces. Like suppose pilot is what controlling the control surfaces. Maybe using a flap, maybe using flap is the high lift device, but maybe using flap, or maybe using a spoiler, which is the air brake, maybe using elevator, maybe using rudder, maybe using aileron. So it's called a pilot control input. So once pilot will use the surfaces or high lift devices, so once it is deflected, so because of that also disturbance created, and these disturbance maybe gust or turbulence, these disturbance are the temporary. Okay, even though pilot control input disturbance also temporary, so these disturbance are temporary. So these disturbance basically hit to the aircraft, and it may becomes like unstable in the sense it may go have a nose up or nose down, something will happen because of this disturbance. Okay, now I am considering suppose nose up occurs. Simply the plane was going like this. Simply the plane was going like this. Here, the plane was going like this only, and because of the disturbance, this airplane goes to. This is now the reference only. Okay. Now this airplane now goes to something like this. What happened here? Because of the disturbance, we got no sub condition. So no sub condition, that is nothing but a moment came, which is nothing but pitch up. So this moment came, obviously it will hit to the aircraft, and it may have a nose up condition. This is now nose up. Nose up. So this nose up, why it came, why it happens? Because of the disturbance. So here obviously you can see the angle of attack is what increased. Okay, if angle of attack is what increased, then if this airplane is what is stable, then what it will try to do? Once the disturbance gone, then this airplane again try to come back to its original position. That is the initial tendency of the static stability. In initial only I had explained, uh, that is definition of the static stability. So this airplane, if suppose it is stable, then this airplane will try to come back to its position once disturbance gone. Okay, so it will have the restoring moment. It will have the restoring moment. This is called restoring moment. restoring moment. Okay, so if it is having restoring moment, then again after disturbance it will try to come back to its original position. Simple. Okay, so increasing angle of attack, whatever the moment acting, and because of that, if angle of attack is what increasing, it is approaching towards the instability. It is going to unstable the aircraft. Why? Because once angle of attack is what increasing, at last what will happen, the angle of attack increase beyond the limit, so the flow will be separated from the surface of the wing, and then loss of lift happens. Then finally the aircraft become unstable and it may have a failure, you can say. Okay, so increasing the angle of attack is basically the negative stability. It is going to destabilize the plane. Okay, increasing the angle of attack. But at the same time, we have a restoring moment. So what restoring moment will try to do? It will try to stabilize the airplane. So how it is stabilizing the airplane? It is trying to get back to its original position. So it will have a nose down now. Once nose down it may have, it means it is trying to get back to its original position. So nose down will be considering as a positive stability. Okay, positive stability. So nose up, negative stability; nose down, positive stability. This sign convention you need to remember. I will write here nose up. Okay, okay, and this nose up or nose down occurring because of the disturbance, and this measurement is basically, okay, why it is nose up? Because of the moment. What moment? Pitching moment. Okay, and this moment change you are getting with respect to angle of attack. Okay, with respect to angle of attack. So dcm by d alpha, this is called pitching moment coefficient change with respect to angle of attack. And if it is nose up, so nose up means increasing angle of attack, so it is going to unstabilize the airplane. Hence dou cm by dou alpha, if it is nose up, then you are going to take, because it is unstabilize the airplane, it is not positive stability, it is not providing positive stability, it is not providing positive stability. So it means this dou cm by dou alpha, or also you consider it is clockwise, it is clockwise. So that time this value dou cm by dou alpha, because it is giving it is going to unstabilize the airplane, so it is give the negative effect to the stability. Okay, so dou cm by dou alpha positive means dou cm by dou alpha greater than 0, it will explain the unstable airplane. Okay, once it is nose down, so what moment we have? Anti-clockwise moment. So anti-clockwise moment you can take negative less than 0, and once nose down we have, then it is now stable airplane. Okay, so always remember, in this way also you can check. This is the very simple way I told you to check the stability, it is stable or unstable. Okay, in case of the longitudinal static stability, so I must say, if it is longitudinal static stability, so if you check dou cm by dou alpha, okay, dou cm by dou alpha is less than 0, it means it is stable, means it is nose down, means it is anti-clockwise. And if it is dou cm by dou alpha, if it is positive, it means it is nose up, it means it is unstable airplane. Always remember this. Okay, so with respect, this is, first of all, this is very important, and for single marks many times this they have asked. Okay, they have asked many times this value. So the pitching moment about cg may must vary with angle of attack, such that any change in angle of attack produces a change of opposite sign in pitching moment about center of gravity, will be called as a stable airplane. Okay, will be called as a stable airplane. So what is the required condition for this static stability for the plane? That dou cm by dou alpha must be negative. Dou cm by dou alpha must be negative. That you need to remember. That you need to remember. Okay, so dou Cm by dou alpha must be negative, and this dou Cm by dou alpha, this dou Cm by dou alpha is negative. It means stable, static stable or stable airplane, simple. This dou Cm by dou alpha also called as pitch stiffness, also called as pitch stiffness. So for static stability, okay, this is the single marks question. For static stability, this is the note point, you make it. For static stability, pitch stiffness must be negative. Okay, question they had asked in gate, no? So for static stability, your stiffness, pitch stiffness must be negative. Negative means restoring moment. Restoring moment means anti-clockwise moment. So anti-clockwise moment considered as the negative value. So dou Cm by dou alpha must be negative. That means it should be less than 0. Simple idea only. Very simple. Okay, right. This is the simple way to understand. Now, here this part is done. If I say dou Cm by dou alpha, that means dou Cm by dou alpha, or it is also called dou Cm Cg by dou alpha. There should not be any confusion. What is the meaning of this? The meaning is very simple. If I am writing Cm Cg, because Cm means what? Pitching moment coefficient. But pitching moment coefficient about what? Pitching moment coefficient, you have to write pitching moment coefficient about Cg, about center of gravity, about Cg, right? About Cg, you have to say dou Cm Cg by dou alpha now onward. Okay? Now onward, you have to say dou Cm Cg by dou alpha. Because pitching moment coefficient, if you are writing also okay, no problem. But pitching moment coefficient, so pitching about what point? So you have to say pitching moment about Cg. That's all. Okay, done. This is the one thing. Second thing, as I told you, the contribution we have to check. Contribution, we have to check the component wise. We have to check the component wise contribution. So first contribution we are going to check for the wing, and in that wing it is main wing, because we have two wing. One is main wing, another is tail wing. So now main wing contribution we are going to check. Main wing contribution, main wing contribution, okay, to the longitudinal static stability, all right.